Hi everyone, in this video we are going to discuss the greenhouse effect. So to start off, I just want to talk about an example that's been in the news a lot lately. So always starts with the sun in this unit. Okay, so here's our sun, and then we're going to talk about a car that has either a dog or a baby in it. So let's draw out like a chair. So here's a car seat or just a regular seat, and then here's a dog. Oh geez. Okay, and then there's some ears, and it's happy. Okay, so we have a dog that's sitting in a car, and then we're going to have to draw a window. So this is our window. Okay, window, dog, chair, and sun. Okay, so we know that the sun emits radiation in terms of UV, Vis, and IR. So it goes through all the way through here into your car, and it goes straight to any dark substances. So anything like a dark chair, or maybe if you have a black steering wheel, that's normally really hot. Your seatbelt can be kind of hot, and so it emits all this energy. Well, it turns out that it's primarily the visible energy that goes through the windows. It transmits the windows. So then your dark surfaces absorb this energy, and some energy is emitted back out in terms of IR radiation. Well, unfortunately, IR radiation is lower in energy, so it actually cannot transmit the window. So it is stuck. It doesn't actually get out of your car. So all of a sudden you have all of this energy that is trapped in your car, and your poor animal is just sitting there. So let's go through this one by one and talk about this. Step one, our sun emits radiation. Now we know this radiation is in three forms. It's UV, it's Vis, and it's IR. Step two, okay, your visible light transmits the window. Step three, your dark objects absorb the energy. Step four, some, and not all of it, some energy is re-emitted as IR radiation. Number five, I'll scroll down just a little bit here. Number five, your IR energy or your IR radiation cannot transmit windows. This is very important. That number five right there is so important, and this is primarily the reason why we have the greenhouse effect. And so now we have trapped energy inside the car. Okay, so your poor dog or baby, I mean really baby, I should be more concerned about that, but I don't have kids, so I'm really concerned about my dogs. And so they're just breathing in all this trapped energy. It's bad. So now your last one is your car gets really hot, like really, really unbelievably hot. It is terrible. So I'm going to ask you a question here just to make sure I've made my point. Is it ever okay to leave a human, so baby, adult, child, whatever, or an animal in a trapped car, especially on a hot day? Go. Did we get an answer? Hopefully we did, because I think I was pretty clear about it before. But is it ever okay to leave a baby or a dog or anything like that inside of a trapped car? No, absolutely not. Please don't do it. It is serious business. The greenhouse effect is real. It traps this IR radiation, and then people or animals inside of a car get really, really hot. They get dehydrated, and then in worst case scenario, they actually die. So please be aware of it, especially on hot days. Protect it. And if you ever see a dog or a baby in a trapped car when it's really hot, call the cops. They'll go, they'll open it up, they'll bring the baby out, and you'll be a hero. So definitely do that. All right, so now let's move forward. Let's actually talk about the greenhouse effect. Now, the greenhouse effect has a very detailed definition, and I'm going to give it to you here, but we need to know it because it has very specific pieces of information in here. All right, so it's a natural process. That's an important part. This happens naturally. This happens all the time on our planet, by which our atmospheric gases trap 80%, so we're very specific here, 80% of the IR radiation emitted by Earth. Okay, primarily we're talking about the Earth's surface. So now when these gases absorb 80% of the IR radiation, that is just considered the greenhouse effect. Now, the more common thing is especially right now in our news, is the enhanced greenhouse effect. Now, the reason I'm talking about the enhanced greenhouse effect is because it has a more colloquial term, but we'll go to that in just a second. So this is when we have more than 80% of IR radiation that is trapped, okay? So this is the enhanced greenhouse effect. So more than 80% of that energy. The reason I'm talking about it is because in our society, we call this global warming. Okay, so whenever you hear global warming in the news, they're really talking about the enhanced greenhouse effect. So we're saying now, we used to have just 80% of our IR radiation trapped. Now it's more than that. And so when you hear global warming, the real definition of global warming is that you have an increase in the average global, so we're talking about the entire planet, temperature. So it's an increase in the average global temperature. Even if it's by 0.1 or 0.2 degrees, that's technically considered global warming. But when you hear global warming from here on out, I want you thinking, all right, that's really the enhanced greenhouse effect. So more than 80% of IR is being trapped. Now, the last thing I want to talk about or clarify is when I say these atmospheric gases, sometimes or more commonly, you're going to hear them referred to as greenhouse gases. So greenhouse gases are very specific as well. They are gases that are capable of absorbing and, okay, so it's both, and emitting IR radiation. This is specific. It's not UV, it's not vis, it's not gamma, it's not micro. It is IR radiation. And so we have some very, very specific examples of this, and yes, you must know every single one of them. The first one, most common, and this one we're going to talk about a lot, carbon dioxide, CO2. The next one, water, H2O. Methane, CH4. We also have nitrous oxide, N2O. Ozone, O3, or our chlorofluorocarbons, or CFCs. And we also know from previous units that there are a significant number of replacements for CFCs that are also greenhouse gases. But these are the ones that I am most concerned with, and we're going to spend a lot of time talking about carbon dioxide. So let's ask one final question before we end this video. And so what I want to ask you is, do we, and when I say we, I mean like humans on Earth, need and want any greenhouse gases in our atmosphere? What do you think? All right, did we get an answer? Hopefully you said yes, because we absolutely need greenhouse gases in our atmosphere. We as humans could not survive on this planet if we did not have our atmosphere there, specifically our greenhouse gases absorbing some of that emitted energy as IR radiation, keeping our planet warm. Because remember, otherwise we would be at negative 18 degrees Celsius, and I don't know about you, but that is way too cold for me. Have a great week. Take care of yourself. Drink water.